In the first video, actually, I tried to show you the IP fabric for EVPN VXLAN, and the underlay protocol was done by BGP. Actually, in the start of the video, I told you that it'll be will be done by iBGP and OSPF, but I just did it by BGP. So in this video, I'll do it with OSPF, and then we move to the next level where we do the overlay. So let's get going. I haven't done any previous configurations for OSPF, so let's get started. So here we are, and if I say show protocols OSPF, so I don't have it running, so let's do it. Set protocol OSPF area 000. You can just put it as 0 also, and interface says XE 000.0 and 1.0, 2.0, and definitely you have to include loop 0 and do it passively because we are not doing any updates on that interface. And that's it. Show compare, you're trying to look what you're trying to add in here, and it's the OSPF is here. I'll commit it. I'll quickly go to spine 2, and we'll quickly run through the same stuff. Set protocol OSPF area 000 and interface Alright, so let's go to leaf 1 and see what will happen to our OSPF configuration. And because we just have 2 spines, so I really should have 2 connections. So here you go. Maybe you hear some background noises. My boy is just making noise all around, so I hope you don't mind that. All right. And you got 2 OSPF neighbors. And what I'll try to do, well, just hold on for a while. And we go for the next leaves. Meantime, we see to let it the OSPF converge. Set protocol OSPF area I'm sorry, actually, I'm not using any kind of special recording softwares or some kind of specific equipment to do this video. It's just a quick time on my Mac, and it's just a plain screen recording. So yeah, you won't see any kind of fancy things, and I'm not even able to do much of editing. I'm just recording the video in one go, and whatever is recorded, I'll just upload. All right, so here you got 2 full neighbors. You can see 2 full neighbors here. And we quickly run to the 3rd leaf. All right, so here we have it. So we got again 2 full neighbors here, and let's try to see if we have all the routes coming in. And from the protocol OSPF, and you can see that we have 1, 2, 11, and 12. So we are learning the routes. And in my previous video I had shown that we had a policy of load balancing per packet in the routing options, so it was doing the load balancing. So let's check if it is doing load balancing for the OSPF learned routes. But before that, you remember in the previous video I had done the BGP as an underlay, and that's very well there. So being in Junos, we have got a lot of facilities. Instead of deleting it, we can just deactivate it, and I'll say deactivate protocol BGP, and the group name is underlay. So my group is deactivated. In configurations it's inactive. I've still not committed it, so if I just commit it, and actually I'm going to throw the same one line on all the 5 nodes, 2 spines, 2 leaves. Deactivate protocol BGP, group underlay. All right, so I believe I've deactivated the protocol BGP on fair number of nodes, so that we do not see any BGP routes in the underlay. So if I say run show routes, so in here I am learning the routes only from excuse me, only OSPF. And if I say run show BGP summary, so BGP is not running. All right, so on the leaves, because you can see that on a leaf excuse me, on leaf 1 you are learning the leaf 2 from spine 2 and from spine 1. So actually on the leaf 2 or leaf 1 or leaf 3 you should be learning the other leaf loopback addresses from 2 paths. So again try run show route, and we have 1 and 2, 11, 12, 11, and yeah, actually 11 is you're directly connected, and 12 and 13 you're learning. So let's try run show a route forwarding table, and the destination is say 13. So it's the same thing what we wanted to achieve in the previous video, that it is doing ECMP. And just to show you the effect of ECMP, I mean it's trying to exit for a particular destination, it's trying to exit from its 2 interfaces. Let's go and deactivate the load balancing policy in the routing options. And it's fairly simple. You can just do deactivate policy options, policy statement, LBPP, and show compare. You're just trying to inactivate it, and I say commit confirmed 2. I'm just committing it for 2 minutes. Okay, so in the policy options, yeah, we have an error here. So okay, so instead of deactivating it, we can just delete it for a minute. So instead of deactivating it, just go ahead and delete it. And I've just did commit confirmed. Okay, edit policy options. And where exactly it's talking about in the policy options, LBPP referenced but not defined, and that's referenced in routing options. Yeah. So we will go in routing options. And we have referenced it here, that's why it's basically giving an error. So we can say delete forwarding table export LBPP top commit confirmed. Before commit confirmed, we can check that what exactly we are removing. So basically we are removing the policy, and we are removing the policy from the routing options. And I'll say commit confirmed 2. Alright, so as soon as you apply this, you can see that it will be rolled back. The very previous command which I was trying to show you for a destination for another leaf loopback address, now you can exit that from just one interface, just because of the normal routing protocol behavior that you have always one best path. Here if you try to see run show route protocol OSPF, and still you are learning 13 from 1 and from 13, but you are taking it as a best path from 0 0, and you are not taking it from 0 1. So it's gonna roll back. Okay, so the next thing is that we have to set up the overlay. Alright, so again, let's get going with the overlay. Alright, so overlay, obviously it's a BGP. In some examples, if you're running through the Juniper documentation, in some examples, or some people who have already uploaded some of their work on internet, you will see that they will do the autonomous system number with local AS number, or in some of them are going to give it in routing options. So you can use either of the method. So edit protocol BGP, we have a deactivated underlay very well there. So let's get going with the overlay. Set group overlay, and we are configuring this on the spine, remember that. And because overlay is iBGP, so we have to set the type as internal, and we will do the authentication. And after that, take it as multipath, and the next thing is that because you have to do the overlay appearing over your loopback addresses, so you will say that your local address is 192.168.100.1, which is your loopback address, and then you can do your neighbors. 192.168.100.2. This is the second spine, and dot 11 is the first leaf, dot 12 is the second leaf, and dot 13 is the third leaf. And do not forget that basically you are trying to do a route reflector, and all of these are your clients, so that you don't have to do a full mesh. It's in the case like right now it looks that way, but I mean, you're not running you're not going to run the BGP from the leaves to leaves. So right, so that's pretty much it. Oh yeah, we didn't do the cluster. Just give it a random IP address and show compare, and in this one you are basically doing this stuff. Commit check. Voila. So our first spine is done. You go to the second spine. We'll quickly try to run through the same configurations. Edit protocol BGP, set group overlay, type internal, local address 192.168.100.2, and I'm sure that in leaf in spine 1 we had a routing options autonomous system number command already there. Drop show routing options. Otherwise it was not, yeah, it was not taking it, so the autonomous system number is very well there. So in here we have in spine 2 we did the local address, we have done it, the type is internal, and just to be sure, top show routing options, and yeah, so the autonomous system number command is very well there. Okay, all right, so for overlay you say that we will use an authentication key. It is doing multipathing. It is having a cluster, so it's part of the same cluster, and you are pairing with the other spine actually, and leaves. Actually, I don't have the facility to pause the video. I'm sorry on that. So I have to run through the configurations of at least 2 leaves and 2 spines. Right, and once we commit it, we'll be able to see that do we have our BGP configuration in a working state or not. So we have the BGP peering for the overlay in an iBGP setup. We got one leaf up with the two spines, and actually this is a single leaf, so it's just a single connectivity. We can go to leaf 2 and fairly quickly try to do the same configuration. Edit protocol, BGP group overlay, set type internal, set authentication key GenCIE, multipath, and the local address is and the neighbors are the spines. So we are having this configuration. All right. Okay, we'll come back to this in a minute, and meantime we configure the third leaf. All right, so that completes our overlay configuration. Well, actually, as of now, it's just iBGP. You are learning your loopbacks over OSPF, and you're just doing iBGP. At the moment, you're not advertising anything. It's very well just the peering, and yeah. So you have your neighbors, and it looks good. But we were talking about EVPN VXLAN, and where does that come into? And yes, so here is a small thing. We say edit group. We have two groups. We are doing overlay at the moment because the underlay is deactivated. So here we have to set some small thing. Set family EVPN signaling. We are doing the EVPN signaling, and as soon as we do the EVPN signaling, it's actually going to bring down the peerings with other, because they don't have the EVPN signaling capability. Actually, I presume that all of you people do know BGP well, so I'll not go to the nuts and bolts of that, like trying to look into the logs and all that stuff, but we can just try to show you a brief snippet. Run show log messages and try to look for last 20, and you can see that capability mismatch is happening over there. Subcode 7 is about capability mismatch, because you are just doing family iNet but the peer is trying to say it's family EVPN, so that's why the peering will go down. That's what we are trying to fix here right now. So in the overlay, we do that the family is EVPN signaling. Set protocol BGP group overlay family EVPN signaling. So all right, so spine 1, spine 2, leaf 1, leaf 2, and this is the third leaf. I'm trying to do it as fast as possible. I hope you don't mind if I'm taking the video too long. All right, so we have changed the family EVPN signaling. So with that one, what should happen, that we should be able to see the peering happening, but now on the different address families, and we should be seeing some more tables in there. So run show BGP summary, we have the established peering with the other ones, but right now, instead of just being INET4 address family, we are basically exchanging BGP EVPN routes. BGP EVPN.0 table is there. Actually, it's going to be empty. If you do run show route, you should see the standard routing table. We are, and on this routing table we are trying to build with OSPF, and yeah, we have still not moved further with the VPN VXLAN configuration, so you'll not see any VXLAN routes here. But this is pretty much it for setting up the underlay and overlay to start with the EVPN VXLAN. And in the start of the video, we had done that we basically deactivated the BGP group underlay, and we brought in OSPF as a protocol, and just to show that the underlay can be done with OSPF or eBGP. But the idea is that you can use both of them, but normally the suggestion is that you do it with eBGP, because it's you got a like ton of nuts and bolts to control your thing, and I mean this is much stable. This is much more controllable than OSPF, because if your involvement is fairly large, and in that case BGP gives you more control. And with that one, I will end this video here. In the next video, we will do bridged overlay, where we just connect some servers with one leaf, and it should go and talk to the other leaf, and so on. And then we have the L3 gateways, and then we will have like two different VNIs, different L3 gateways, and then we'll try to make them talk to each other, and so on. Thanks a lot for watching, and I hope this is something of a benefit for you.